Hello, 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 hello. It is almost time for undocking. I don't think we're going to get to PDI today. I'm not going to lie. Probably not going to happen. But undocking and most likely descent orbit insertion. I still have to go back and capture that. What were we doing then? It was the. It has something to do with the computer. I still gotta capture that from the stream. IMU, thank you. Docked IMU align. Still gotta capture that and upload it. But I figured I just have a small backlog of videos so that I can keep content pushing even when I'm not streaming. So that's the plan. Also, I apologize ahead of time, but I just ate dinner, so I've got that post-eating like thick saliva and cough going on. So bear with me. That's probably gonna go away after a while, hopefully. If not, I apologize. So yeah, without further ado, I would say let's get into it. So here we are. Start recording. So yeah, LEM undocking time. So S-band voice to voice. ECM. We enable ranging now. B transmitter to voice. Biomed right. Bitrate high. What time is undocking? Let me take a look at that real quick. I have it saved all on my paper, but my desk is really crammed because I'm back at school, so. Yeah, I don't remember what time undocking is. Let's take a look here. Could be in the checklist on the other vehicles, so let's go over there. So it's SEP burn minus 25 minutes. So SEP burn minus 25. That would be 100 hours, 15 minutes. 100 hours, 15 minutes. So we need to start a timer for 14 minutes, 30 seconds. Or here, 14, 30 seconds, counting down. Already past the time. Damn it. 13 minutes. Five, four, three, two, one. Mark. Okay. Guidance control, eggs, radar, just preparing all the switch positions. Here we go. This is the landing radar computer. And over here we select eggs, that's good. Pulse, pulse, pulse. At hold, at hold. TTCA jets. Rendezvous radar goes to slew. ACA 4 jets disabled. TTCA translation disabled for the system engineer. Circuit breaker heaters. Where is it? AOT closed. There it is. Install COAS. It's installed. And now verify circuit breakers for undocking. Just going to have the checklist go through and look at that. Cross tie bus open. Sequence camera close. Okay, and we'll get the DAP going. So verb 48, enter. Verb 21, enter. 21102, enter. Proceed. Verb 34, enter. And now we'll start the thrust monitoring program. Verb 37, enter. 47, enter. And while we're waiting for that to load on the computer, we're going to come to the eggs and we're going to set our counters to 0. So 404, 405, and 406 monitor your translation on the X, Y, and Z axes respectively. And then 470 just monitors it like the EMS. So that's exactly what this is. So we're just going to make it all 0, exactly as it would appear on the computer. So 404 plus 0, 405 plus 0, 406 plus 0, and 470 readout. And now we're waiting. So at this point, we'll switch to the command module. And now we just got that countdown then. So let's ensure that we have the tunnel vent vented all the way. And I would say that by now it's probably good. So we will go back to off. And now it's just a matter of waiting. So we'll bring it down very, very slowly here. $13, $14. Alright, and here we go. Five, 4, 3, 2, 1. Disengage. And there we go. So now we just need to null 470.
Rotation, translation.
So to null that, we would thrust up. Just there we go.
Rotation, translation.
That's the key. Okay. .470 is nulled. So yeah, you're just gonna do the 2 key. I was doing 6 because the body axis translation stuff. Body axis stuff is slightly different, but so that's what I was doing. So we're gonna have to thrust aft slightly like that. There we go. Now verb 37, enter, 00, enter. Now we get to go back to the CM. Visually null translation and rates.
Translation.
I said that looks pretty good. Maybe we just gotta come a little to the right, but other than that, no, that looks good. Alright, switching back to the lem. Okay, so we're going to yaw left 60 degrees. Yawing left 60 degrees.
Rotation.
Look at that. Ooh, that's awesome. How's that, huh? Okay. Let's pitch up. that's fine, yeah. Oh, that looks great. That looks so good. If our math is right on this one, this is going to put us right down into... we'll be looking straight at the CSM. There it is. There it is. Okay. Yeah, that, honestly, that just looks unbelievable. Just a little bit of an overshoot there. Okay. So local vertical. While we're waiting for that to load up on the computer, I already know. Render distance. This sometimes happens, and that's just solved by doing that. Now we can see the whole thing, and it looks nice. So that should be 238. Sure, so take it up a little bit. Seeing the element, yeah, no, it's really cool. By the way, you're gonna laugh at my rendezvous in the LEM, because for whatever reason, I never can get it to rendezvous at the docking attitude. It's actually insane. I get it to rendezvous, just the docking attitude's completely wrong then. I have to spin the CSM around because I guess my skills are not too good with rendezvous, but yeah, you'll see what I'm talking about later. So that's rather unfortunate, but we get the mission done in the end, so it's no problem. As long as it's done. They're going to report tracker light, make sure that it works, and we can even come up into here and say, hey, you know, Apollo, or hey, Eagle, your tracker light works. We'll say, good. Tracker light works. It's going off now. Now S-band antenna pitch goes to 123. And yaw goes to -40, and it's already there. Track mode to auto. And now we're going to do that yaw 360. So that is 5 degrees. Rate scale, 5 degrees per second. So that's 1, 2, 3, 4, 5. Okay, so 1 degree here. So take us yaw mode to pulse. And we are going to yaw left at 1 degree per second for LEM inspection. Should we take a look at the lemon inspection from the CM? You only got a few seconds to decide before we spin all the way around. Should we take a look at it from the CM? I say, you know what the hell, let's look at it from the CM. The way it was supposed to be looked at. Lem inspection. There you go. While we're doing that, P30. That is my bad pen that I use as a bookmark. By the way, don't throw out your bad pens. Use them as bookmarks. P30, DOI. This is at 101.3949.54 minus 0071.2 minus 0000.0 minus 0002.6, and that's dx, dy, dz, and then it's going to be a 59.9 by 8.8 orbit. Relative delta V is 71.3. Relative delta V. Burn time is going to be 30 seconds. And the FDAI roll, so the attitude for the burn is 0 roll and 284 pitch, and of course, because of the LEM's design, yaw doesn't matter at all. The eggs delta V, 71.2, DX eggs, minus 1, 2, 3, 5, DY eggs, and minus 0, 2.8 DZ eggs. And of course, not applicable, not applicable, not applicable. No remarks. Okay, while we're waiting for our yaw around, to make sure that we have the maximum amount of time we can be doing this for, let's get started on that uplink as well. I don't know if the uplink will continue in this computer if we switch vehicles, so just in case. Good evening, good evening. It's good to see you, James. We've already undocked. We are doing that inspection, LEM inspection. How many uplinks are we getting? 3 uplinks. Okay, we're gonna have to be on the ball with this one. So sorry I couldn't keep doing this, but I wanted to make sure we had the utmost time. Alright, there she is. Uplink complete. Yeah, sorry we couldn't keep looking at the LEM from the CM, but I wanted to make sure we had the most amount of time possible in this cool phase before the separation. Somebody's upside down. We will not be getting the 1201 or 1202 alarms. That requires file modifications that I don't know how to do. Alright, ready for stabilizing.
Translation. Rotation.
And we are stable. Verb 76, enter. Guidance control pings. Yaw to mode control. Lem active station keeping. And we did get our MCC update. Now we're just waiting on our abort pads. And we are actually going to be getting a ridiculous amount of pads coming in. So much so that doing this RCS burn is going to be impossible, getting all these pads down plus doing the RCS burn on our own. So we're actually going to have to pause to record all these pads. Yeah, no, we can't get to 1201 and 1202 because modern computers are just too fast at processing. So, and also you can't simulate the electrical shortage. So in order to get that alarm, you actually have to physically slow down the runtime on the AGC. And that's not something we're going to be doing. There you go. Just get us nice and stable. Look at that. Beautiful. Okay, here's our PDI pad. Yeah, as I said, these are coming in really fast. In fact, I don't even know if we're gonna copy down the abort pads. They're gonna come in so fast. So here's PDI pad, which occurs at 102.3652.62, and our to go noun 61, so 9 minutes and 50 seconds to the pitch over, basically, on noun 61. Cross range should be minus 0.0 or minus 0.1 nautical miles. And attitude is 180 roll, 287 pitch, and 0 yaw. DETA 231 if required, plus 56936 on the DETA, 231 if required. Okay. Yeah, things are happening fast now, so forgive me for pausing. I know it's a cardinal sin, but things are just happening way too fast now. So we've got our PDI pad. Come over here, clear this out. Okay, 232 plus 00600, enter, clear. Now, 232 and 233. I don't remember exactly what they are. Let me find that information out. Well, it's quite simple. They could write their normal speed because, again, I'm the one that has to perform the SEP burn in a few minutes. The guys in 11 didn't do that. Right, so this is injection altitudes. 232 is your injection altitude, and then 233, so we're inserting into a 60 nautical mile orbit, basically. And 233 is the pitch profile. That's what we're looking at. So, yep, 232 was the insertion, and 233 is our pitch profile for an abort. So 233 plus 00250, enter, clear, 404 readout. Looks good. 405 readout. Looks good. 406 readout. Remember, this is the PIPA counts on the axes. Now we're looking at 464 and 465. So those are going to be the vertical pitch steering altitude rate threshold. Vertical pitch steering altitude rate threshold. That's what this is. 464 plus 00500, enter, clear, and 465. What this address is it is the target radial rate at orbit insertion. So that's plus 00195, enter, clear. And remember, all these that I'm entering in, they're for Apollo 11. Every mission has different ones. 616 is the ullage counter value for ullage completion, and 623 is 623 is the orientation Z body axis parallel to plane when guidance steering is commanded. So take 616 to 0 and 623 to 0. Next one is 224, 225, 226, 227, and 231. So 224 is, so this is redefining the orbit. Semi-major axes computation at orbit insertion, the lower limit, the upper limit, and then 230, or 227, 227 is the constant in theta, and 231 is the nominal lunar landing site radius. Yeah, so lots of different things you got to enter into this computer. Lots of different things. So 224 plus 60267, enter. 225 plus 58148, enter. 226 plus 70312, enter. 227 minus 50031, enter. By the way, yes, it is required to hit clear every time you hit enter. 699. Okay, back to the scene. Command module separation. So verb 37, enter, 30, enter. And that sep time is at a GET of 100 hours, 40 minutes, and 44 seconds. The delta V is 0, 0, minus 2.5. Proceed. Yeah, we might miss this. I sincerely hope not, but it's looking woof at this point. 61 by 59.6. That's good. Proceed. Port pad, just ignore it now. 1, 2, fuck, 6. 1, 2, 3, 4. Okay, any specific attitude? 0, 15, 0. Okay, so just an aft translation then. That's good. We may not run out of time after all. Delta V set is 2.5. Okay. Rate 2, rate 2, rate 2. 2. CMC. So verb 48. 11102 11111. Proceed. Command module weight is 37958. Verb 21, enter, plus 37958, enter. Proceed. Gimbal angles don't matter. Proceed. Verb 46, enter. Rect on. DET is set. CMC is an auto. Verb 49. Verb 22. Plus 0, 1, 5, 0, 0. Enter. And proceed. Proceed. Verb 37, enter. 41, enter. Proceed. Attitude 1, rate 2. Trans control power is on.
Rotation. Translation.
We are in translation. Woo! Yeah, that's close. Holy smokes, that's really close. Damn. Wow, that's cutting it close. With one person, that's so much harder than Apollo 12. Again, abort pad, we're ignoring them for now. "30 seconds.
Rotation. Translation.
Okay, here we go. 9, 8, 7, 6, 5, 4, 3, 2, 1. Burn. Oop, that's the opposite. Nope, that is the right thing. Yes. It's minus X until the EMS reads 5, like so. Okay. Standby off. I'm so used to bringing it to 0 that's immediately what I tried to do. And yeah, no, not bringing it to 0 this time. Bringing it to 5 instead. That's really good. Orbit insertion. DET stop. Reset. Exterior rendezvous light on. Running lights on. Yeah, well, for starters, Turi had the pad papers already printed out, so I have to write down what each row means, because I don't have those papers printed out. But secondly, I'm pretty sure he might have taken a photo of the pads as they were rolling in on high-intensity situations, and then written them down later. I can't do that, though, because I have to use my phone for the chat. But yeah, these are really hard. So we're waiting for a lunar surface pad. Now that is one I definitely need to copy down. We do see the LEM is drifting slightly. Let's take pings to auto and see if it will hold that in. If not, what we can do is we can just go to eggs. Eggs, deadband min. And that'll bring her down and stop her from rotating. We don't want to do that too much, though, because, as you can see, we've actually already used 5% of our fuel. So the LEM has limited RCS, but it has always enjoyed a surplus of RCS throughout the whole mission, but it is still limited. You can't go crazy with it. So we are waiting for our lunar surface pad still. And then let's just switch to command module. It doesn't matter which vehicle we're in for that, so we can be in this one, because we're waiting for an MCC update next. Okay, here's our T2 abort. And our T3 abort. We're going to go external for this because it just makes it a little bit easier on my eyes. So let's find out where the lunar module is. Right there. It's all the way back there. It's getting real small now. Let's actually switch to it. Just because it looks more interesting in my opinion. While I copy this down. We got lots of time to copy pads down now, so we're good in that. T2 abort is 102.58.31.28 TIG and 103.56 9.00, that's phasing TIG. We do got that LEM update, so let's actually continue with our tests then. So circuit breaker pings, landing radar closed. Temp monitor to landing. And we can see LR, it's in the white zone, that's good. Altitude rate. Radar test. Landing. Altitude transmitter and velocity transmitter look good. And this has driven to the proper stuff. I will do a computer test of that, so verb 63, enter. Verb 22, enter. 2, enter. Proceed. Okay, good. Proceed. And this is also good. It's verb 34, enter. Landing antenna goes to auto now. Verb 60, enter. Verb 63, enter. Verb 22, enter. 2, enter. Proceed. Landing radar to descent. And we should get that 522 alarm. Yep, so verb 05, noun 09, enter. 522 alarm, we do get that. Landing radar back to auto. And verb 34, enter. And radar test off. And landing radar circuit breaker open. Now we can do that uplink that they're requesting from us. The lights on the LEM I don't have turned on right now. You can see the crew standing in the LEM. Okay, uplink complete. Verb 37, enter. 00, enter. That's off. And now we'll do our eggs downlink as soon as that's done. Here we go. Verb 47, enter. Clear. 414 plus 1 0 0 0 0. Enter. Clear. 414 readout and proceed on Disky. While we're waiting for that downlink, let's continue copying stuff down. Okay, and then it's 106.43 37.00, and that's CSI TIG 109 1330.00, and that's TPI, TIG. Great. So verb 83, enter. Our T3 abort. (104, 43, 30) TIG. So it's 335 there. Yeah, I mean, that's pretty good. Just need to take it down just a little bit. And a little more. Right about that much is good. Because we're off a little bit in our roll and our yaw, so it's going to look a little interesting, but that should be good. So good there. (317) readout. 440 readout. Right, so I suppose 317. So 317, that is the range from the CSM, and 440 is that range rate. So that's what we're checking up on. And then 277, if you guys don't remember, 277 is that in-plane angle between z-axis and local horizon. And so we're essentially just making sure 227 should match the readout from -50, so that's 360 -50, yep, and that looks good. So we're good there. I was not done writing down that T3 abort, but it's gone now, so oh well. 400 plus 2. 0000. Enter. Clear. Alright, so 400 plus 2. So if we take a look at the 400s, 400 plus 2 is the Z body axis steering mode. So if the eggs is in control, the attitude error signals will drive the Z body axis in the estimated direction of the CSM if S sub 507 is 0, or in the desired thrust direction if F sub 507 is 1. Hello, Sangtron. That was kind of strange. We took these landmarks like cities and then superimpose the star over it. Very strange. Yes, that's program 23. We do that in Apollo 12, but not in Apollo 11. Apollo 11 is the standard substellar point. Apollo 12 actually does the landmark superimposed directly onto the star form of marking, which is much easier, except in NASP, for reasons. So 507 plus 0 is going to do the same thing as 400 plus 2, by the way. So mode control, so we need to take guidance control to pings, and now mode control eggs to auto. So if we ever get to needing the abort eggs, so we check the needles. Eggs will now go to at hold. Now we'll load up those delta V counts. External delta V. This is program 30, descent orbit insertion pad. Verb 37, enter. Oh, I suppose, hold on. Let's stop recording. NASP has this, by the way. NASP has everything that they show off you can do in NASP. Just letting you know. Start recording. Okay, descent orbit insertion prep. So here, we're starting this at the verb 37, enter 30. So we're starting it at the P30 external delta V. We did a little bit of the prep before that, but it was sort of bundled into separation because it happened so very quickly. So just come up to the program 30 for this one. So this is 101.3949.54, proceed. Minus 71.2, minus 0, minus 2.6, proceed. CSM rescue. CSM rescue. Pad. That is phase 33 is 103.4407.00. TPI, if PDI less than 10 is 105, 16, 16.00. Okay, so 59, 8.8, that looks good. I like those numbers. Let's get that event timer. Stop, reset, 10, 20, 30, 40. 10, 20, 30, 40, count down. Start. Looks good. Proceed. 0, 0, enter. Verb 76, enter. Rendezvous radar close. Close. Temp, rendezvous radar, RR in the white, that's good. To slew. And now we need to manually lock on to the CM. So that CM should still be sort of above and in front, so not much yaw is required, but we do need to get a little bit down. It's always really difficult to find the CM at this point, I noticed. So instead, what I think we're going to do is we're just going to take a quick breather to finish copying. Oh, and look at that. Would you look at that? We got a new DOI time, 101.39, 49.54, minus 71.2, minus 2.6. Okay, so nothing about that has changed at all. So we're good there. I'm gonna move my mic. I'm sorry, I can't. It's absolutely slowing me down. It's getting in the way. Too stressful of a time to be doing this. I have two pads I couldn't even copy down. So if the pad's not important, I'm just not going to copy it for the time being. Yeah, I don't know what it is, but I literally cannot, for the life of me, find the command module on the rendezvous radar. So, fuck it. Skip it. We'll just omit that, and we'll go right to the ranging test. Plus 0. Verb 41. Noun 72. Enter. Plus 2.5. Enter. Plus 28300. Proceed. Verb 16. Noun 72. Enter. Alright. Back to the command module, because we got shit to do in here too. 7, enter, 0, 0, enter. Accept the uplink. VHF AM A off, B duplex. VHF rate on. Ranging. Set norm. Okay, 11.4 nautical miles away. Verb 37, enter. Verb 37, enter. 2, 0, enter. Let's not get in a panic. We still have plenty of time plenty of time to check out the rendezvous radar, so we will go back. We'll try and do that. I can't, for whatever reason, for the life of me, I cannot find the fucking CM with the radar manually, so we're going to run program 20 in the LEM and see how that fares. But we are acquiring, and the optics are also tracking the lunar module, so that's very nice. Verb 56, enter, 00, enter, and go SCS. Back to the LEM. Right, let's try and do this test again here. But this time, we are going to do verb 37, enter, 20, enter. And we're also going to give us a verb 44, enter. You can see our attitude is apparently still decent. Just waiting for it to think. Go pings to auto, and let's see what the LGC comes up with. Right, we do have a lock. Or at least we have a rate. We have a range rate, not a lock yet. But there it is, there's the lock. I also realized why I couldn't find the CM with the radar is because I didn't have it set to AGC. Well, whip-de-fucking-do. I had the knob wrong. Yikes. But 10.77 nautical miles away. And over here we're 13.8, so this discrepancy is not too bad, all things considered. So we can terminate program 20, back to pings at hold, and do our verb 41, noun 72, enter. Plus 00000, enter, plus 283.00. By the way, for those of you who don't know why I just dismissed that few nautical miles discrepancy, is because we are probably side lobe locked. And that can get you a few nautical miles off when you're locked onto a side lobe. So we're just like, okay, we're probably locked onto a side lobe, but otherwise these numbers look good. I don't have the time to fidget around with the radar to see if we're not in a side lobe, so we're just not gonna do that right now. And we don't have the time. Verb 44, enter. Now we got our P52. So AOT lamp, close. And we need to come up to here. Make sure that we are on the F detent. There we go. So verb 37, enter, 52, enter. Verb 22, enter, 3, enter. Proceed. guidance control pings. Proceed. And let's see what she comes up with. Star 231. That looks really good. Proceed on that. And proceed. We will acquire star 231. Sorry, detent 2 star 31. So the whole lem is moving as it should be. We can see star 31 is actually covered. So we'll hit enter, and instead we will designate to 232. And proceed on that. Once we've redesignated to 232, we're going to take manual control again. And we are going to do hard over command. And we're just going to get acquired here. So we'll go back to that. Verb 76, enter. Okay, so when it crosses over the x-axis, we mark with Q, mark, and when it crosses over the y-axis, we mark with Y. So, Y, and that makes the first pair. Here comes the second pair, 2. Okay. Three. 4. 4. There we go. That completes our marks. Proceed. And here we go. Pings to auto. Proceed. Proceed. Things to hold, enter, proceed. Now we do our marks like regular. Mark. 1. So that's X, Y, X, Y, X, Y, X, Y. There we go. That completes those marks. And look at that. Good difference. So we're good to proceed on that. Proceed on that. Enter on that. So verb 34, enter. And 00, enter. back to maximal impulse, verb 77. AOT lamp open. And then select detent CL. And now DOI. So we are, wow, almost actually perfectly timed with this. So the checklist is just auto proceeding through a few things. Now we need to perform our main propulsion system unstaged checks. So that's just going to run through. If that's good, then we don't have to do anything. We'll cycle CWE. Gotta cycle CWE before some of these burns. I know, it's really annoying. Just have to deal with it. Throttle control, manual CDR, throttle to minimum, and that already is. Propellant quantity, we're gonna mark on descent 1. 95% fuel, that's looking good. So we did all of that. We did the rendezvous radar test. All of that it's all good. And we had about 5 minutes to spare. So that gives you any inclination on how difficult this stuff is. Yeah. Yeah, this is very, very tight. In Apollo 12, it's not so tight. So, while we got time to kill, I'm gonna go refill my water. Hope you guys thoroughly enjoyed what the lunar module optics looked like. But we're 15 minutes from DOI, so... I'll be back. Okay, I returned. Yeah, I don't know if they'll have the optics. Just wait till you see what doing the optics on the ground looks like. If you're wondering what that spiral's for, that's what it's for. The spiral is used to generate a third, let's see, so there's 1, 2, it's used to generate a third and a fourth spatial dimension. So it's really important, right? Because in the command module you have 5 spatial dimensions. You've got your roll, your pitch, your yaw, and then your shaft and your trunnion angles. In the lunar module, you don't have your roll, pitch, and your yaw because you're sort of on the ground and the moon is moving, right? So instead, you have your detent angle, up, down, left, right angle. So that's 2, up, down, and left, right. And then you have the cursor position, which forms the sub X and Y, like in the thing, there's that sort of subspace, X and Y axes, and then the cursor forms a dimension of the difference from the epicenter of the optics. And those are your 4 spatial dimensions in there. So, yeah, no, it's good. It's good. I like it. Anyways, we're gonna continue trucking along here. Okay, so let's do it. Verb 37, enter, 40, enter. Attitude for the burn. Roll, they said was about 0, and yaw should be about 284, so that looks good. So we're good to proceed on that. Of course, pings is not in auto. Now we're good to proceed on that. Circuit breaker, EPS, inverter 1, close. Mode select to pings. And we'll perform our eggs update now. So verb 47, enter. This is required pretty much before and after every burn, so get used to this procedure. Oh, you know what? Actually, there is a 5th spatial dimension in the lunar surface star tracking in the LEM. It's actually the time of ephemeris. So it's the actual position of the moon is the 5th spatial dimension. Okay, we've got +0 here. We'll clear that out. Now we're just waiting for the flashing verb noun here. There we go. Proceed. Tracker mode. Over here, we'll go slew. Oh, sorry. Slew. And it's going to be 213 and +27. S-band select aft, bitrate low, B transmitter data, and we'll get our verb 83 in now. And now we'll do our data stuff. 317 readouts. That's our range, remember? Here's our range rate. Good. Now we're waiting up for you. There it goes. Noun 20. Enter. Verb 40. Enter. Okay. Now we'll do an eggs and pings alignment. So 400 +3. And that should complete the eggs and pings alignment. Very small torque. And yep, it's complete. So now let's check our 277. 53.25, looking good. We'll go 400 +1 now. Proceed here. And now we'll do 410 plus 50000. So address 410 is something we haven't seen yet, so let me get it up for you. Address 410. This is pre-thrust steering. So 410 plus 5 activates the external delta V mode. So it will drive it to the attitude based on what's required for the burn. And it will derive that attitude based on what we put into 450, 451, and 452. So that's what that is, essentially. So we'll do our verb 06, noun 86, and here this is sort of the eggs delta V display. We take the first 3 rows, or we take the rows in the disky and we enter them into the eggs. First row gets 450, 450 minus 00712, enter, clear, 451 minus 5 balls, enter, clear, and 452 minus 00028. There we go. Now we can do our 411 readout, and that should be our, I think this is our burned delta V, and then 407 monitors remaining. Hold on. Let me look this up. 411. I seem to be misremembering what these are. 411 is the actual thrust direction of the LEM. Depends upon the engine being used. The dips and RCS engines are assumed to be thrusting along the X-body axis, and the APS engine is assumed canted through nominal angles. If the APS engine is being used, this address value should be entered. If an abort stage occurs, right, so this is the abort. This is just telling us if it's X-axis burn or nominal angle burn, canted nominal angle burn. So if it's canted nominal angle, +1 will be entered. If it's through the X-axis, +0. So that's what that is. So that's good that it should read 0. And 407. 407 is reference frame selector for external delta V. So this just tells us which axes we're going to be burning on, essentially. This should always be +0 nominally. And if you need Z body steering, it'll be +1 just prior to thrusting. But we need X body steering, so we'll leave it at +0. So that's what that is for. Back at it, key release on the computer. Enter. Enter. And now we just need to wait for that 4-minute mark. So you can see this part is pretty chill. It's pretty chill so far. Yeah, how late are you guys available for? Because I don't know, like I'm starting to think maybe we actually get to PDI today. PDI takes about 25 to 30 minutes to touchdown. So it's a bit of a time investment. And that doesn't even include the amount of time preparing for it. So it is a little bit of an investment. But seeing how fast we're cruising through this, I mean, it's not bad. Alright, 4 minutes. We'll make sure all our circuit breakers are set properly. Abort stage needs to be closed now. AELD needs to be closed. On the other side now, AELD should be closed. Abort stage closed. Attitude translation for jets. Balance coupler on. Good. Abort stage are reset. Pings auto, eggs at hold. Engine stop, reset. Good. Verb 77, enter. Alright, sounds good. It looks like we may get to PDI after all. I hope I don't crash. Let me tell you guys, I haven't practiced PDI in, oh my god, probably years. So, woo. I hope I'm not gonna crash. It's gonna be so bad if I crash. It'll be so embarrassing. I'd probably just end the stream there, to be honest. Okay, T-minus 1 minute. Master arm on. Just in case we need to abort. Well, actually, abort will actually cause master arm to be on anyways. I don't know why we need it on. Probably just in case. Waiting on that disky blank, so we'll come over here for a 500 real fast. And the disky blank should be at 35 seconds on this one. Different programs have different disky blank periods on the LGC. So we got disky blank. Engine arm descent, 500. Official readout. And that's the total delta B we need to burn now. So a few things are going to happen. At 7.5 seconds, we're going to get that ullage. Then we hit proceed. 8, 7, 6, 5, proceed. 3, 2, 1, time up. Oh, that was not counting up, that was setting the thing. So we'll just look at this. When this hits 45 seconds, we're gonna throttle up to 40%. Here we go, throttle up, 40%. Take a look at commanded versus actual thrust. We're controlling actual thrust here. Command shows our throttle position, actual thrust shows the real throttle. And that's what we're looking at. There we go, and cut off. Engine stop, push button, push. Engine arm off. Master arm off. Proceed. Let's take a look at our residuals. They should be really small. So 500 has a +1. Good. 501. -6. That's good. And 502. +4. Okay, that's good. TTCA jets and translation enable. And so for the X and the Z axes, we need to null those residuals. So
Translation.
X axes, we need to thrust up, up slightly. Just a few puffs. Unlike the CM, this counter goes to 0. And now Z should be aft. Nope, forward. And again, just a puff up. So we nulled out our X and our Z axes. That's good. Proceed. 0, 0. Enter. Pings to at hold. And now we are going to pitch down until pitch equals 195. So, switch balls.
Rotation.
Now we'll get that nice pitch down. So we'll go, again, pitch should go to direct. Oop. It's an auto, most likely. This fucking at hold. Is it a pulse? Nope. Really wants to fight with me. Let's do. There. I don't know why it wants to fight with me so bad. Fine. Okay, 195. Now we'll begin our insertion routine. So 410 plus 00, enter. And we'll do verb 82, enter. Proceed. Quantity monitor off. And we're going to close the rendezvous radar circuit breakers. LGC, very good. Verb 95, enter. Translation disabled.
Translation. Rotation.
Good. And now verb 37, enter. 20, enter. While that's loading, we can do 400 plus 2. Verb 76, enter. Mode control ags to auto. Check our air needles. Look at that. That is really something else. Okay, so let's just verify that we do have that lock. Take it a little left. Good. Little right. Yep, so back to the left. That's what we're basically checking. Are we side lobe locked? If we are, we got problems. And it looks like we are not. So back to the right. Back up to that 2. Take it a little up. Let's see, is it side lobe locked there? Nope. Take it down. Side lobe locked in this direction. Nope, so we're good. You can see how we could trick it into side lobe locking. Very bad. But it's good. So we got it on that proper lobe there. Now let's do that verb 63 test. The transmitter will go to off at DOI plus 10. So when this hits 50, we'll compare range with CSM. Look at that. What do you think? This is actually looking pretty crazy, huh? There's the terrain. Oh yeah, just to show you, now that we have the sunlight, this is the LEM steerable antenna. So if we come over here, and we do this, you can see what that's all about. That's the steerable. Does it in both pitch and yaw directions. Like that. So that's pretty cool. And this is the S-band aft antenna here. This is the forward antenna. And then this is obviously the rendezvous radar. This big honking thing, that's the rendezvous radar. Good, that killed enough time. So we're at that 50-minute mark now. Let's switch to the CM. 89.8. No, that's well within discrepancy. I would say that that's pretty normal. Well within the discrepancies. So verb 34, enter. Open, open. $400 plus 2. Enter. 400 plus 0. Enter. Verb 25. Noun 07. Enter. 110. Enter. 40. Enter. Enter. And now we're going to wait to the 45-minute mark, and then we're going to load our PDI plus 12 abort pad. I don't think I have that, actually. I do have that. I do have that, yes. PDI plus 12 pad. That is 102, 48, 46.32 GET. And that's plus 0117.0 DX. Plus 0000.1 DY, and plus 0168.1 DZ. Nice, I do have that. That's good. So we'll bring it down slowly to the 45-minute mark. Real quick, we're also just going to double check. PCM bitrate should be low in the command module. We're not counting down to anything. This is actually elapsed time from the burn. So here we're 15 minutes elapsed from the burn. So let's get that target load on P30 in case we abort. Verb 37, enter. 30, enter. Time of ignition is verb 25, enter. Plus 00102 enter, plus 00048, enter, plus 04632, enter, proceed, desired delta V, plus 01170, enter, plus 00001, enter, plus 01681, enter, proceed. LGC really takes a long time to calculate some of this stuff. And we're also drifting out of attitude here. Which is strange, because before it was fighting me not wanting to change attitude. Now all of a sudden it is wanting to change attitude. It's... I don't know what it is, why it chooses to do the things it chooses to do. I have it on attitude hold, so it should be holding attitude. But it's not. And it's making me irritated. So now, at this point, we're just going to assume zero roll, zero yaw, and then we are going to pitch down to 125 degrees here. Then we're going to actually go pings auto. And now, pitch should be direct. Yeah, see, now it wants to fight. Uh-huh. Auto will have it hold attitude, but apparently attitude hold will not have it hold attitude. But it was before. Very strange. Whatever. 125. We'll go at hold now. Properly at hold. Now, when we hit 40 minutes on the countdown, we are going to begin that yaw 180, and we're going to face retro attitude. Forward just ever so slightly. T minus 40 minutes, or not T minus, sorry, T plus 20 minutes. Yawing left, 180 degrees. Again, see? Pulse, direct. Nah, attitude hold. Does it fine. Doesn't hold attitude on the rest of the axes, though. That's for damn sure. Yeah, I sometimes I don't understand the ping's guidance control. So usually when it has these manual maneuvers, I'll usually go to ags at hold, because that seems to do what I would expect and what pings should be doing, in my opinion. But you know, that's not how it worked. So I don't know why attitude hold is not actually holding attitude here. I think it's probably because I need to hit verb 77 or something on the computer. but the checklist hasn't told me to do that, so I'm not going to. But yep, we are officially facing the retro direction now. Stabilize. Old Man Rebel better get in here. He is missing out. Yeah, see, look. Verb 77. That's probably what I need to hit in order for attitude hold to work properly, right? Let's test it out. We're in at hold. Yaw to mode control. Now let's see. Ah, yes. Okay, so that's for sure what it was then. Just needed to hit that verb 77. Okay, fair is fair. Verb 83, enter. He's gonna miss a damn landing. Oh yeah, I never did stop recording for DOI. Oops, let me do that. Alright, there we go. PDI preparations. Yay. Yeah, compared to the CSM only missions, this is probably going to be a clusterfuck of, like, everything's just sort of meshed together. The CSM ones are nice, you can separate them all nicely, but, like, the LEM stuff is just, it's all happening too fast to mesh, or to separate things out. You're sort of forced to deal with the meshing of everything, so. Only way I would do this is if I just didn't care about making a landing. I had, like, a save or something. Oh, speaking of which, let's save. Holy crap. And then I just keep reloading. I do one thing, and then I reload. And then I do another thing, and then I reload, basically. That's the only way that's probably going to work out. But yeah, COAS, let's mount it on the overhead, and we'll get that overhead COAS turned on. Verb 37, enter. 52, enter. Look at that, another P52. Verb 22, enter. Option 3, proceed. We are apparently going to enter on that. And verb 21, enter. It's going to be 546, enter. Proceed. Doesn't say, we should be very much near the attitude, so proceed. Very close to attitude, yep. So verb 76, enter. Verb 06, noun to 0, enter. So enter on mark. Oh yeah. Hello. Enter. Enter. Noun 22. Okay, looks good. Verb 34. Apparently just doing the sun check. I think for burn attitude purposes. Or something. I'm not entirely sure what that's all about, but I just followed the checklist to do that. Pitch 2, 180, 285. Now, would that be this mode? I think it would be. So we'll pitch up to 285. Here, we'll go pitch up to 200 and 90. That would make this 85 to 85. Auto. At DOI plus 30. So DOI plus 35 is also PDI minus 25. But at DOI plus 30, we're going to turn on our inverter. Well, actually it is on already, but switch it to inverter 1, that is. Everything's situated here. Yeah, eggs is a backup to the pings, exactly. However, it's used side by side. Eggs has a lot of really, really cool and useful features that you're just normally going to use. So, I like the eggs. I used to hate it, but I like it now. I got the PDF next to me, and whenever I'm like, what address is this? I don't remember what this means. I just entered it on the PDF, and it spits me out what it means. So yeah. We'll go to primary inverter now. Verify all that is closed. We'll cycle CWE. Get the master alarm. Engine stop. Reset. And auto throttle. Alright, here's where I'm probably going to have to move my microphone. Again, back away from the computer. I'm going to need 2 hands for this. It's actually 35. Okay, so actually, believe it or not, the elapsed time on this is really in sync with our time of ignition anyways. So, yeah, here's where it's going to start getting crazy. Let's get down to that 25-minute mark. And as you can see, we look really low right now, and that's the whole point. 25 minutes, so batteries 5 and 6 coming online. Get that rendezvous radar closed, and we'll try and establish our Cat 2 lock. So verb 37, enter, 20, enter. And we get the computer is thinking alarm. Yes, yes, come on. Hurry up, I don't have all day. Come on. We need our Cat 2 lock. Let's go. Let's go. Come on. Hurry up. Oh my god. The computer picks the worst times, I swear to god. Okay. Go. So we'll get our noun 18, and we're just going to enter to bypass. And that should drive the rendezvous radar, hopefully. Alright, let's see what she does. Okay. It looks like it's doing a search. for the CM right now. And it's possible the CM is entirely behind us. And I think it is, so that rendezvous radar is going to have to come all the way around. Definition of sometime today, sweetie. Yeah, for real. There we are. Okay. We're in, and it's coming down. Let's see if we can't get that mode 2 lock. We need that Cat 2 autopilot to land this. By the way, no, the LEM actually does have Cat 2 landing autopilot. So, if worse comes to worse, we let the computer land if I get overwhelmed. But what's the fun in that? I'd rather crash than do that, honestly. All right, let's do a check for main lobe here. We are good in that up direction. We are good in the down direction. I say we're good left and right. So, yep, we got it. Right there. That is definitely the main lobe. So we're auto track now. Verb 56, enter. Verb 37, enter. 00, enter. Verb 37, enter. 63, enter. How to make the computer land? You simply just don't touch anything. It's literally that easy. You just don't touch anything and the computer will land for you entirely.
Translation. Rotation.
Okay, just making sure we're on rotation for that landing. Alright. Did I ever cycle the recording? Am I officially recording, like, PDI preparation? I don't remember. Fuck it, we'll just leave it. I got better things to do, like land. So stop, reset. 10, 11, 12, 13, 14, 15, 16, 10, 20, 30, counting down. Let's just make sure that that's set up right. Good. There we go. Proceed. Manually trim to burn attitude. 287. I'm gonna actually, you know what? I'm gonna say, let's have the auto do it. Just to make sure I'm in the proper burn attitude, we do get to program alarm. Oh, hold on. Verb 34, enter. 63, enter. I know what you're trying to do. Okay. No, we can't do that. I see what you're trying to do. Yeah, that's a sextant star position check. That's not what I thought I was bypassing there. 270, 280, yeah, roughly 287, yeah. Okay, in that case, we will proceed here. Enter to bypass that. Now we get our autopilot. Propellant quantity gauging, descent 1. Let's get the steerable kicked around to 219. And plus 30, which it pretty much already is. Needs a little fine-tuning there. Bitrate goes to high, biomed goes to left, and we are officially going to cancel cabin pressurization. Standing by for T-minus 15. We're a little underneath it, but that's okay. Proceed. Okay, looks like we are in that burn attitude really good. Are you guys ready? Are you guys ready? It is officially power descent initiate, so we are actually going to rename the stream to Undocking, DOI, and PDI. Okay, we are so close. There is so much stuff to do with the eggs and stuff before we fire this engine, but it is unbelievably close. At this point, I'm going to move my microphone back. How do I sound? Am I a little quieter now? That shouldn't be too bad. Do I still sound good? I mean, I know my microphone is absolutely ass, but, is it okay? Yeah, whatever microphone I had over the summer, I need to get that thing. And I looked it up, and it was like 170 euros. I was like, no way. Ain't no way. We're not landing in the football field-sized crater. There was a problem which had caused them to be downrange too much. That doesn't happen in this because we didn't do anything to cause that problem. We executed everything perfectly. So that problem isn't going to exist for us. In fact, we are going to land exactly where they would have landed had they not been too far downrange. Look at that. Go for PDI. We gotta go for PDI. Okay. D-minus 10 minutes. Bringing it down. D-minus 10. We'll get that last eggs update performed. Bitrate high. Verb 47. Enter. 414 plus 1. Proceed. How far off target were they? They were over 8 miles off target. You'll actually see if I land on the spot. You'll see how far off. It's pretty far. They had some significant downrange. Waiting for the disky to finish cleaning things up with that downlink. Proceed. Okay, looks like we do require that 231. So that's gonna be 240 plus, and then it was the 231 if required. Part of the pad, we enter that in, 56936. So this is the RLS number.
And then 262 minus 00150. Enter. Clear. Again, this is all stuff for like all stuff for aborts and telling it where we think we're gonna land, things like that, that are given in the flight plan. So we don't much need to really educate ourselves on what they mean, because they're fixed. Once they're set, they're set. They don't really serve any other purpose. The burn stuff. Addresses for burns are mostly the important stuff. So that's what we're really looking for. OHW less than 34 degrees, and PDI minus 6 minutes. Standing by. Yeah, so here with this one, 317 should match the first row of the disky, minus the fact that it's rounded, and then 440 should match the second row of the disky, pretty much, minus the fact that it's a little rounded. Okay, coming up on that T-minus 6 minutes mark. Six minutes. Now in 20. Oops, sorry, that was verb. Now in 20. Verb 40. 400 plus 3. Enter. 400 readout. No CDU transients. 400 plus 1. Enter. 433. Readout. This is our velocity indicator. Proceed. Proceed. T-minus 5 minutes. Circuit breaker, landing radar, close. Bring her down to T-minus 4. Let's make a save here. Yes. T-minus 4. T-minus 4. Proceed. Enter. We should get down 62. Circuit breakers check. Switch position check. I don't think the LM gets the Velcro diagrams. Nope. It does not. We are getting some kind of heater alarm. I don't know what it's for, because all of our heater circuit breakers are indeed closed, so... rate scale, 25. Attitude translation 4 jets. Balance coupler on. Engine enable on. Engine command override off. All ports reset. Minimum. Mode control, mode control, mode control. Pings and eggs in auto. PDI, T-minus 3 minutes. Looks good here. Burp 77. Yaw zeroed out. There she goes. Got pitch taken care of. Alright, and we got that attitude good. Standing by. We are going to lose our Cat 2 lock at some point. T-minus 35 seconds. Engine arm descent. (19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, ullage, 7, 6, 5, proceed, 3, 2, 1, ignition. Descent engine command override on. Throttle up. This is the thrust to weight ratio, believe it or not. Okay, T plus 1 minute. HW less than 10 degrees. Good. Right now, this is our range and range rate from the CM. Pretty soon, we're going to display the altitude check. Okay, LPD altitude. Looks like 484, 48,000 feet remaining to the ground. T plus 2 minutes, that's good. We are still go for PDI. Still go for PDI, they said. Still go for PDI. Okay, let's get an altitude check. Altitude. Just a hair above 47, and it agrees with the computer so far, obviously, because we're on the computer selecting mode. Coming up on T plus 3 minutes. Here we do our landing position check and our OHW check yet again, and we're looking good so far. Apollo 11 starts heads down. It's the only mission that does its heads down. We are 3 minutes in, so yaw right. That S-band set up. Minus, sorry, this is plus 12. Minus 14. They chose to do it on Apollo 11 so that they could see where they were going, to see if everything was good. Just to sort of have a visual check for the software. Yeah. Okay, standing by. Our altitude and velocity lights are out, so at time of ignition +5, we're gonna take a look at that data. Alright, we are tick +5, so let's just double check. Are our staging batteries good? Explosive device bats are good. We got the very lovely view of Earth out the window. Let's give us a 1668. Here's our 1668. And it looks like our Delta H is doing pretty good so far. As soon as it starts to converge, we'll accept that data. And I think it's pretty stable. So we'll go P57, enter, and that'll converge right down to 0. Yep, okay. Delta H is converging. Seconds. We did get the throttle down. Very nice. Let's go pings at hold. Evaluate manual control. Okay, very good on attitude control here. Back to auto. Time of G was 9 minutes 30 seconds, if I remember, 9 minutes 50 seconds, so we're very shortly going to be coming up on that. Y'all, I am so stressed. I'm so stressed for this right now. Oh, this is crazy. T+8. Okay, let's get our 1668 back up. Pitch over in T-1 minute, 30 seconds. Yeah, Jumped the gun on that a bit much. Let's get the next thing set up, which is a 223 plus 00020, but do not enter. Okay, we've got our P64. Thrust is at 50. Thrust is decreasing. Landing site visible. Hover. Key release. Proceed. I do not think we need to redesignate. I think we're good there. 2000. Okay, ready? Ready for manual control. 4, 3, 2, 1. Going manual. Okay. Down. Nice and gently. See, now we're rising. So I need to take this down. Throttle that down. There we go. Alright, bring that altitude back down. I'm slightly concerned with the fuel, to be honest. Percent fuel, and we're only at I don't know. We might run out of fuel here. Hard to say. Here's what we're gonna do. Very risky maneuver. Drifting. Okay, a little hard. A little hard. But we're down. Holy shit. And we didn't immediately get... Okay, AC out on detent, come on. We didn't immediately get problems, so... stop push button, push. ACA out of detent, come on. Yeah, we didn't get the very loud alarm, which means that our crew has actually somehow survived that impact. Yeah, I couldn't get the ROD under control, and I realized it was because, for whatever reason, our throttle command and our actual throttle had somehow diverged. So, yay, I guess. Engine command override off. Engine arm off. Yeah, I lived and the Lem lived. And yeah, you can hit this hard enough to actually die. Actually, maybe I just didn't get the alarm noise. Hold on, let me just double check that we lived. If not, we're gonna do that again. Nope, we lived. Okay. Nice. Enable, 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 main subs, open, open, crossfeed closed, E1, open, open. Okay. Woo! That was crazy. Verb 44, enter. And let's just get that maneuver enter. Let's just get that maneuver underway. Oh my god, yeah, we just kept going up, and I was like, alright, you know what, we're just gonna cut the engine mid-air. How about that? This doesn't work in real life, by the way. I don't know if you guys know this, but there's something called ullage. Well, the moon does have gravity, to be honest, though. But no, I don't think it would work. I don't think it would work in real life. But we did it. We're down. And if someone's really bothered, I can do it again. I didn't realize that the, for whatever reason, the commanded throttle was diverged from the auto throttle. And that's what caused the problem. When we switched to at hold to manual throttle, it just bumped straight up to like 100. and sent us going way up. Otherwise, we would have had the perfect fuel, really good landing, but we didn't. So that's just how it ends up being sometimes, I guess. Okay. Master arm on. Descent vent. Fire. Master arm off. At PDI plus 14, we take the oxidizer vent open. I don't know why these start open, but yeah, whatever. Just dump all the fuel, it doesn't matter. Circuit breaker, landing radar open. AOT will go forward. Slew rendezvous radar to X axes. Okay. Ah, that Verb 97 might be an abort. Stay for T2. Let's take a look. AOT back to CL. Yeah, if you guys would like to try that again, I can absolutely do that again. I'll pay attention to the throttle this time. Verb 37, enter, 68, enter. Contact light doesn't stay on after you cut the engine off. When you disarm the engine, the contact light turns off. Here, let's try. If we arm the descent engine, will the light turn back on? Nope. Okay. There's some kind of logic that makes it turn off after a bit. You would not mind round 2? You know what? Honestly, neither would I. Let's go for round 2. That was our practice, okay? That doesn't count. That's our practice run, right? Doesn't count. I told you guys I haven't done the landing in like years, so there's our one practice run. Now it's the real run. Now it's the real deal, not a simulation. Let's do it. I'm gonna cut the recording here. And yeah, we're just gonna pretend like that last PDI didn't happen. But that was the simulation landing. Yeah, that doesn't count. So we're looking for stream 0002. Yeah, that doesn't count. Didn't count. We had a tremendous landing. Totally did not have to cut off the engine due to fuel problems. throttle problems, that is. Our fuel, it would have been such a good amount of fuel too. We probably would have landed with like 5 or 4% fuel. but I kicked it into at old, and when I went manual throttle, it sent that throttle all the way up. And damn, once you start ascending, you no longer have enough fuel to land, so it's immediately an abort type situation. So is that banging being picked up on my mic? I swear to God. It is. Okay. Now, can someone get Reb in here? Rebel needs to see this. Okay, that's good. I can see it getting picked up, but maybe my noise filter or my notch filter is doing an okay job. Oh yeah, Steam. Is he on Steam right now? Let's check. He's offline. He's offline. Damn it. Reb, where are you? He said he wanted to see the landing. I swear to God, every time I say, hey, we're doing this phase of the mission, he's like, I want to see it. I want to see it. And then he never shows up. He never shows up. Well, I guess. Wife and kids, right? I don't have to deal with the wife or kids part. So. Alright, you guys ready? Picking up at PDI plus 4 minutes. You guys ready? 5, 4, 3, 2, 1. Sim start. Or sim, I mean, this is the actual attempt. What am I talking about? Yes, last one was the simulation. Here's the real attempt now. Proceed. Enter. Okay, let's be absolutely certain, right? TTCA is minimum. Okay, it's real this time. Let's get it down. Okay, rate scale 25. Throttle auto. Attitude translation 4. Jets balance coupler on. Engine gimbal on. Descent engine command override off. Abort stage reset. Attitude to band minimum. Mode control. Eggs and pings auto. Engine stop. Push button reset. T minus 3 minutes. Sequence camera is on. Give us a verb 77. Alright, let's bring it down. Bring it down calmly, slowly. 1 minute. 35 seconds and counting. Disky blank, engine arm, descent. 26, 25, 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, ullage, sieve, 6, 5, verb 99, proceed, 2, 1, ignition. Got the timer perfect that time. Nice. And look at that, the throttle and the command agree with each other. Very nice. Descent engine fan override on, stand by for throttle up. Alright, we are go throttle up. 2, 1, throttle up. Yeah, I don't know what's causing it. All our heaters are plugged in. I'll have to inspect that later. 1 minute, and we're good. Let's see, heaters. Yeah, I don't know. Caution warning reset doesn't fix it either. Our temps are, honestly, they're good. S-band temp is good too. Couldn't tell ya. Oh, well now it's out. Hey, look at that. I don't know what I did. Or I don't know, just some heater just needed to heat something more, or maybe changing this back and forth, reset its logic. I don't know. Couldn't tell you, but 2 minutes, and our altitude check is right on the line. We're right on the line. And look at that, our throttles agree with each other. That's good. Okay, thread started, thread completed. We are still go for PDI at 2 minutes. We are go. Coming up on 2 and 30. Let's get ourselves an altitude check. Let's see here. Should show around 47,200. 47,200. Down to 47. Okay, look at that. So this display is working properly, and at T plus 3 minutes. Position checks right on the line. Yaw over. Master alarm. What is it? S-band probably. Rendezvous radar. Okay, pitch minus 14. Yaw plus 12. Okay, we are on the steerable and tracking. Yeah, we broke radar lock a bit too fast there, so we got the alarm for it. All's well. Coming up on 5 minutes. time we'll get it right. Our throttles are matched, so we'll get it right this time. We were doing so well, too. It's really unfortunate. Okay, 5 minutes. Let's check our staging batteries, ED batteries, explosive devices. They're good. Get our 1668 in. Verb 16, noun 68. Enter. 1668 looks good. So delta H is within limits. Give us verb 57. We'll accept that data. Delta H is coming right down to 0 very nicely. Still converging. We get the terrain every once in a while, but it's converging and it's almost down to 0. So working on that. Key release. Okay, standing by for that 57%. Manual throttle is minimum all the way down. 50-some%. Come on. Throttle down. There we go. Looks like we're a little bit ahead. Manual control is good. Feet, 11,000 feet, coming up on 8 minutes. We'll get our 1668 in. Again. Pitch over, should be happening soon. Let's get our 223 plus 00020, and we'll stand by to enter that. Pitch over. That's P64. Antenna mode hover. Key release. Coming up on 9 minutes. Proceed. We do not need to redesignate. $2,000 feet. Ags is in. Okay, here we come. control. Okay, down at 5. Drifting a little forward. Picking up some dust. Contact. Woo! And that is how you do that. That is how you do that. Okay, stop push buttons pushed. ACA out of detent. Eggs and pings to auto. Nissan engine command override off. Engine arm off. Port 13 is in. 414 is in. Get the ascent feeds. RCS. Back to the command module. That was literally textbook. Holy smokes. That was great. How much fuel do we have left? 6%. That's pretty good. Master arm on. Descent vent fire. Master arm off. Wow, that was spectacular. Holy smokes. That first time, yeah, it was that throttle. You know, it was really good up until that throttle differential for whatever reason. But once I made sure the throttles matched, that landing was textbook. That was great. Damn, that was good. Very stressful. were ahead of schedule even, too. That's how good the landing was. Landing radar open. AOT forward. Stay for T1. Stay for T1. Oh, yes, hold on. Slew. What? Go. There you go. It's a beautiful shot of the Earth, by the way. Thank you guys, thank you. Couldn't have done it without you guys. Alright, T plus 16. Let's get our 68 verb. Look at that, and we're not verb 97, which means the computer's not calling for an abort now, which is always nice. The EVAs in NASPAR are nothing to write home about. They're kind of the same as in re-entry, to be honest. Okay. Got our latitude, longitude, and altitude, so that's it. We'll record these values real quick. Landing CRD plus 00069 plus 02373 and minus 0. Okay. I think at this point we're going to stop and we're going to do our sort of lunar stay portion of this. So stop recording here. Lunar stay. So proceed. Engine stop reset. 1, 2, enter. And I don't think I did ever record the PDI plus 23-minute abort. So... oh, wait, yeah, I think I actually... I did, actually. And that's going to be 102, 58, I did, actually. 31:28. Proceed. Proceed. Stop. Reset. 1, 2, 3. Okay. What did you say, few to? 400 plus 1. 225. See, no, this I didn't write down, that's for sure. I don't know what 225 and 226 are. Oh well. We missed it on one of the abort pads, that's fine. F410 plus 0. Propellant quantity off. And now we can open the fuel vent as well. Stay for T2. Stay for T2. Ascent. Looks good. Consumables look pretty good as well. Okay. Verb 37, enter, 00, enter. Verb 76. Mode control, eggs to off. Double check RCS. Okay. Ascent ECA control close. Battery 5 off, battery 6 off. Switching to inverter 2. I'm not sure what happened with the fuel lines, to be honest. Couldn't tell you. Deca power open. Descent engine override open. Ascent ECA control open. Seaweed cycle. Yes, it seems that cycling seaweed causes the heater light to come on, and then it goes off after a while. Interesting. Interesting. Very interesting. Yep, there it goes. It's off now. Interesting. 047 readout. And that looks alright. 053 readout. 623. 544. 545. 546. 400 plus 6, 0, 0, 0, 0. Enter. So eggs can calibrate now. 232 readout. It's good. 465. And this is going to be an insertion target. Will be 0. 465. Insertion target. Plus 00320. Enter. And it goes to 400 readout, and eggs is still in calibration mode. It's not a bug. I don't think. It might actually behave like that. I don't think it's a bug. Yep. That gets rid of the heater light just cycling through all them. I don't think it's a bug. It seems to be very intentional behavior. Anyways, while we're waiting on that, let's get our cabin pressure situated. And we can get the guys out of the suit. Okay, they're in the cabin now. Very nice. Yeah, it would be cool if they could see this. This is a really good sim, so... Okay. Verb 37, enter 57. Oh, yes, hold on. This is one of those moments now where I'd actually like to make a new video. I haven't been titling these videos at all, so rest in peace. I'm gonna have to watch them all. Start recording. Yeah, some of these are like hours long. Okay, program 57. Refs mat and gravity alignment option. So it looks like we're not doing stars, just gravity lines. So yep, verb 37, enter, 57, enter. Verb 22, enter. 3, enter for option refs mat. Proceed, and our specific alignment technique is going to be verb 22, enter, refs mat, and gravity. So that's number 1, enter. Proceed. Now we can do verb 16, noun 20, enter, and we're just sort of going to monitor this and the ball. So you see, you get to know attitude light twice. This will change. It'll take another measurement. And then the key release light is going to flash. When that happens, simply hit key release and follow it up with a verb 32, because we're going to need to make 2 measurements. So, well, it does make 2 measurements, but 2 sets of measurements, that is. 2 sets of measurements. Release. So here's our error which is 75, displayed on the top row. The other two rows just don't refresh. They're not supposed to show anything right now, though. But we can hit a verb 32, enter, and retake our measurements here, and hopefully get that number looking a little lower. To show you guys how far off Tranquility Base is, that's where Tranquility is, and here's where they were supposed to land. So yeah, roughly about 8 miles. Okay, we're taking the last measurement here. Forgot how long these measurements take. Oh, there we go. Here's our error. It's now just 1, which is good. Proceed. Here's our new ICDU angles. Proceed on that. There we go. There's our angle difference. It is 0. That's good. Proceed. Delta R, delta P, delta Y. That's good. Verb 34. Enter. And the US is 0, 0. Enter. Fuel vent close. Now we can 0 the CDU. So verb 40, now 20. Enter. .544 readout. Good. 545 readout. Now just remember that this is our count for the calibration in X, Y, and Z, so that's all pretty good. And now we can do an eggs and pings aligns. 400 plus 3. Enter. Go. Eggs and pings are now aligned. And now we can do a 400. Just make sure that that's plus 0. Good. 400 plus 4. Okay, looking good. So now it's going to be P57 with the star marking. And once that's done, I think I'm going to call it quits for the night. So we'll get to see how that's done. And then I'm going to call it quits. PCM bitrate. RCS quantity looks pretty good too. Rendezvous radar circuit breaker close. We're supposed to wait 30 seconds before closing the pings one, but it hasn't done anything bad, so I just left it as is. H2 separator. Tripped out. 1 second. Push. And that should clear that up in a second. Okay. For 40, noun 72. Enter. That zeroes the rendezvous radar CDU, and now we can tell it to move to position 0 and 283. Verb 16, noun 72, and we can monitor that now. The reason we're needing this to move is because we need to take our marks, and the radar is in the way correctly, so we put it in the stow position, get it out of the way. Yep, there we go. H2 set plate is good now. We can take that caution warning reset back to the set. We will be doing an EVA, of course. There's something really cool I have to show you guys. So circuit breaker open, verb 44, so we tell the computer to stop commanding the rendezvous radar to gimbal, and now we start program 57. Again, option 3 is already selected, so we're good there. Proceed. This time, we're going to do option 2 on specific technique, which is 2 celestial bodies. Proceed. So the flight plan tells us to use detent 6 star 12. So 612, enter, and proceed. It's going to give us a predicted position and spiral code. Proceed. It's going to remind us again what star. It's star 12. Proceed. So now what we need to do is we need to find star 12. There it is. Now we bring this is called the cursor. We bring this to the star, like so. And we take a mark. After we mark, we need to write this number down. So this is 144. 0.45. And now what we do is we bring the spiral to the star. And we make sure it's nice positioned in the center. No mark necessary on this one. Just the cursor. And now we write down that angle, which is 263.00. I'm surprised it came out that cleanly. Now on the disky, you're going to load cursor and spiral angles. So verb 24, enter, and you're going to load it in. Plus 14445, enter, plus 26300, enter, And now you're going to do verb 32, enter. And you're going to repeat this process again. So bring the cursor to the star. Mark. Write the number down. You can see this is 144.7, and let's just give this a small nudge to see if this is increasing. Yeah, 0.71. There we go. Come over here, and now we'll bring the spiral to the star. And write that angle down. 262.3. This is 0.3. I would say that's 0.32 or 33. So verb 24. Enter. Plus 14471. Enter. Plus 26233. Enter. Verb 32. Enter. And now do that one more time. Bring it through the center of the star. Mark. Write the numbers down. That's about 0.64. And bring the spiral to the star. Try and get it as center as possible. That 262.33. Again, verb 24. Enter. Plus 14464. Enter. Plus 26233. Enter. Now we hit proceed, and we need to select the next star. That next star is going to be star 3 on detent 4. So verb 21, select detent 4, and we're marking star 03. Enter. And now proceed. This is the predicted cursor spiral code. Proceed. And we're reminded, detent 3, star 3. Yes, these marks give you the exact location of where you landed. Well, no, actually. These marks align the IMU. Proceed. Now we'll find star 3 in detent 3. So there's 3, and this is probably detent 3. Just based on its position. So, again, mark. And this should be 0.27.19. It actually might not be the correct detent here. Let's see. Yep, so hold on. Not the correct detent. So we hit E for mark reject. To remark here. And now this number is 146.46, and bring that over. That's 090.7372. Verb 24, enter, plus 14646, enter, plus 09072, enter, verb 32, enter, take another mark. We might get a high angle difference because of that first mark, but we'll see. We did manually re-enter the data, so mark. It's 146.339. Yeah, I will say it's 39. And bring that cursor over. So this is the part that no one knows about. Like, everyone is like, what is the spiral? I've heard about the spiral. I have always dreamed of seeing the spiral. Well, now you have seen the spiral. And you know what it is. Verb 24. Enter. Plus 146.39. Enter. Plus 09068. Enter. And we do more. Yeah, it has to be different than the command module, because the command module system would never work. Mark. That's 146.45. And 090.6. Now 6.4. Just 6.4. So verb 24. Enter. Plus 146.45. Enter. Plus 09064. Enter. Proceed. You can see 2. That's a pretty good number, actually. Now, we're going to close the rendezvous radar circuit breakers. Verb 41, now in 72. And we put the rendezvous radar back in its parking position. And while that's happening, I'm going to record this pad that popped up a long time ago. So P22, auto optics. And this is a landmark ID of the lunar module. Yes, this does technically allow us to track the LEM. They don't have us do it in Apollo 11 though, but I might do it just for shits and giggles, to be honest. Because tracking the lunar module is actually really cool. So, but we will see it a lot in Apollo 12 when I get to Apollo 12. Probably never. I've done it before. I've completed the mission already, but I still have a lot of things planned. The tutorials for the lunar series are not going as great as I thought they would because, well, to be honest, things are happening too fast to even separate out videos. So I might just kind of just upload all these in bulk, I guess, and just title them Part 1, Part 2, Part 3, and I guess we'll just all have to suffer together. If we got time, though, we'll definitely do that. But that's the radar back in its parking position. or 44. Enter. Here's our difference. Proceed. Here's our deltas, excuse me. Proceed. So the IMU realigns. And enter. And here is our latitude, longitude, and altitude. So pretty good there. Proceed to accept, verb 34 to reject. We are going to press proceed and accept because the pad, or the numbers we got out are very close to the ones we got from our pad, which is probably why we got them. So 400 plus 3, so this is going to do an exit pings align. There we go. Exit pings align is good. Now we'll do 413 plus 1. Enter. 047. Readouts. 37773. Good. And 053 readout. Minus 77212. And your numbers should be about the same for this. Is there any sims on donning spacesuits? Yes, in the lunar module. In the command module, there is not, but in the lunar module, there is a screen, and I have to toggle them between the suit and stuff. Now, this isn't something like simulate putting the suit on, but it simulates you using the suit consumables. So yeah, that does complete the P57s, so we'll stop there. Anyways, so thank you all for joining, and I'm glad we could get on the ground. Pause, save. So with that, I think I'm going to wrap it up for the night. Thank you all for joining. And yeah, I don't know what I'm going to do with these recordings, to be honest. I have no idea. I might just upload this entire stream and just say that this is the undocking DOI and PDI tutorial. And then I'll upload that little short bit about the P57s that we just did. Anyways, yeah, it's been a great time. Thank you guys. By the way, if you're wondering, this photo, the Gemini spacecraft, I took that photo from a real-life photo they took, and then I just painted my own Gemini spacecraft over that photo. So that is my rendition of the, I think this was Gemini, I think this is Gemini 6. The two Geminis rendezvoused, they took the photo, and so that middle piece I painted. Using Photoshop, but it's still a digital painting. You know, I didn't come out here with a brush and pen, obviously, but or a brush and paint, but digital paint. But yeah, if you're wondering what that was. Thank you guys for joining. I hope you have a great night. Thank you very much. Yeah, I did remove all that squiggly bullshit coming out of the back of the adapter segment, because that would have been impossible to paint. So I removed it and instead
there is that stuff, and it's very detailed. There's a lot of depth to it. So this is an art piece that took me, I think, about like, I want to say it's like 60 to 70 hours. Because I had to do the contour for all the lines and all the little details, and then paint it. And so this is the best piece of art, honestly, I have ever made. My art sucks. So this was so far above my expectations of my abilities going into the Photoshop class, but no, it's great. So thank you guys for watching, and I'll see you all soon. Oh yeah, by the way, I suppose if you guys want, I can show you around my stationeer's base. But I'll stop the stream and probably either record or start up new streams. Anyways, we're stopping now. Oh, actually no. Look at the time. I changed my mind. We're not gonna do that. It's too late. See? It's very late, so we'll do that. I don't know. Maybe I'll record it. But yeah. Anyways, thank you guys for stopping by.